Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on hydrogen bonding. In our last lesson, we discussed the formation of metallic bonds. We learned that metallic bonding occurs as a result of the attraction between metal ions and their surrounding sea of electrons. We also learned that, unlike the electrons in other elements, those that are in metals are delocalized and free-moving. As a result, metals are electrically and thermally conductive, as well as being malleable and ductile. The crystal lattice structure of metal remains intact, while the atoms bend and shift freely. In today's lesson, we will define the term intermolecular force. We will also explain the process of hydrogen bonding. We will discuss the effects that hydrogen bonding has on the properties of different substances. Let us get started right away, students. Intermolecular forces are relatively weak forces of attraction that occur between molecules. While these forces vary in strength, they are typically weaker than the bonds that connect atoms in molecules. Intermolecular forces are also usually weaker than the bond that joins ions in ionic compounds and metal atoms in solid metals. There are several different types of intermolecular forces that act between molecules, including dipole-dipole forces, London dispersion forces, and hydrogen bonding. We will discuss hydrogen bonding now and the other two types of forces in later lessons. Students, look at these molecules. Are they polar or nonpolar? What type of intermolecular forces do you think exist between them? Write your answers on a piece of paper, and I will see you in a few minutes.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, everyone. Let us answer these questions together now so that you can make any necessary corrections. Ammonia, water, and hydrogen fluoride molecules are all polar. The intermolecular forces that exist between them are hydrogen bonds. If you answered those correctly, great work. Did you know that hydrogen bonds are stronger than ordinary dipole forces? While dipole-dipole forces are only about 1% as strong as covalent bonds, hydrogen bonds are about 5 to 10% as strong. Hydrogen bonding is a particular type of intermolecular force arising when a hydrogen atom is bonded to highly electronegative elements such as fluorine, oxygen, and nitrogen. In other words, hydrogen bonding is a specific type of dipole-dipole interaction. This interaction occurs between polar compounds. Within these compounds, there are large differences in electronegativity between the hydrogen and the fluorine, oxygen, or nitrogen. This difference in electronegativity makes the bonds that connect them highly polar. hydrogen atoms are given partially positive charge due to this polarity. In addition, the small size of the hydrogen atoms brings them quite close to an unshared pair of electrons on an adjacent molecule. Hydrogen bonding is the reason that certain compounds have such unusually high boiling points. Some examples of these compounds include hydrogen fluoride, water, and ammonia. How do we represent hydrogen bonds in diagrams? They are often shown as a dotted line drawn between the hydrogen atom and the unshared electron pair of the highly electronegative atom to which it is attracted. Let us look at an example. The hydrogen bond in hydrogen fluoride occurs when the highly electronegative fluorine atom attracts the hydrogen atom of an adjacent molecule. Students, define the terms intermolecular forces and hydrogen bonding. Then, describe the effects that hydrogen bonding has on the properties of certain compounds. You may begin when you are ready.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. Let us take a few minutes and discuss the answers together. Intermolecular forces are defined as the relatively weak forces of attraction that occur between molecules. Hydrogen bonding is a specific type of dipole-dipole interaction that occurs between polar compounds. It is a specific kind of intermolecular force that arises when a hydrogen atom is bonded to highly electronegative elements such as fluorine, oxygen, and nitrogen. Hydrogen bonding affects the properties of compounds such as water, ammonia, and hydrogen fluoride by giving them relatively high boiling points. Did you complete this activity correctly? If so, you are doing well. If you had some trouble with this activity, please review your notes at the end of this lesson. Today, we discussed intermolecular forces. We defined them as the relatively weak forces of attraction that occur between molecules. We learned about a specific type of intermolecular force known as hydrogen bonding. Hydrogen bonding is a specific type of dipole-dipole interaction that occurs between polar compounds. However, hydrogen bonding is stronger than ordinary dipole forces. We learned that it is a particular type of intermolecular force that occurs when a hydrogen atom is bonded to highly electronegative elements such as fluorine, oxygen, and nitrogen. We also learned that hydrogen bonding is responsible for the high boiling point of certain compounds. In our next lesson, we will describe van der Waals forces. We will also explain dipole-dipole force. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.